Hello, in this video we're going to look at a complex fraction which contains negative exponents. The first thing we'll do with a problem like this is we'll go ahead and use this rule from the exponents set of rules that we had in the past. X to the negative n equals 1 over x to the n to convert these negative exponents into positive ones. So the expression can be written as 1 over x cubed plus 1 over y cubed over 1 over x squared plus 1 over y squared. Now the problem looks more like a classic complex fraction problem. So we've discussed different ways of doing these in the past, but the easiest approach would be to find the LCD for all four of these denominators. And of course, if you remember, the procedure for finding an LCD is once you have put all the items that you want to find the least common multiple of in prime factored form, then you're simply going to multiply the highest power of all factors to get your LCD. In this case, we can see this is very simple. We have a factor of x and a factor of y. The highest power of x that we see is x cubed. The highest power of y that we see is y cubed in any of these four denominators. So the LCD here, according to this algorithm, is just going to be x cubed y cubed, which is an expression sufficient enough for each of these denominators to go into. And what we will do now is we will go ahead and multiply that LCD x cubed y cubed on the top, and of course we have to distribute. So let's go ahead and distribute right away so we don't have to rewrite all this again. So we're just going to get x cubed y cubed multiplied by both of those terms because of distribution, and we'll do the same down here in the main denominator of the main complex fraction. So we will go ahead and multiply x cubed y cubed by both of those terms, and we end up with this situation. Notice that we're only multiplying once on the top and once on the bottom, but then we have to distribute. That's why we see this written next to each of the terms. And the reason we can multiply in that way is because basically, if you think about it, we're multiplying by x cubed y cubed over x cubed y cubed, which is just 1. So that's why we actually get to do it. Now, as we do so, we notice that there's some cross-canceling that becomes possible. We notice that this x cubed will cross-cancel with that. The y cube here will cross-cancel with this y cube. Down here, the x squared and the y cube do cross-cancel, but they leave us an x on the top. Here, in the next term, y squared and y cube cancel out as well, and they leave us a y on the top. So now we see that on the top, we're left with y cubed plus x cubed over, downstairs we have x y cubed plus x cubed y. Now, with problems like this, it's really important not to stop too early and to make sure that there's no more simplification possible. So to that end, we'll try to factor both the numerator and the denominator as much as possible to see if there is any cross-canceling possible. On the top, we notice that we have a sum of cubes, which we can factor according to this formula: f cubed plus l cubed equals f plus l times f squared plus actually minus fl plus l squared. And here our f is going to be y and l is going to be x. So we end up with this factorization, y plus x times y squared minus xy plus x squared. And in the denominator, we notice that we have a common factor of xy, and that leaves us y squared plus x squared. Now, we notice that even though we completely factored both the numerator and the denominator, there is still no legal cancellation that's possible, because we of course cannot cancel within those factors like that, because those would be terms when they're inside the group, and we can't cross cancel terms. So basically this was as good as things we're going to get. So even though both of these would be correct answers, we usually go ahead and leave that as the final answer after we've verified that there's no simplification that's possible. But you should definitely try to simplify further, because as you know, in math textbooks and math software such as MyMathLab, the final answer that is expected is always the simplest form of the answer. And that's basically how you approach a problem like this. So until the next time we meet, be safe.